Maritime Made is sponsored by Invest Nova Scotia because great things are happening. Invest Nova Scotia connects your business with the right resources and opportunities. InvestNovaScotia.ca.
Ace Machining is a metal fabrication shop located in Dartmouth, Nova Scotia. They manufacture parts for other companies who use them to build their own products. The manufacturing process begins with approved designs for each part. They'll be manufacturing using a variety of materials.
In 2008, I had decided I saw a need for a manufacturing facility in the Woodside Industrial Park. We had found a company that was going out of business in Nova Scotia, rural Nova Scotia, and we bought the assets, brought them to Woodside in Dartmouth, felt that there was a need in the Woodside Industrial Park for manufacturing. We're a job shop, so in the manufacturing world, you have companies that make their own products. We're a shop that we manufacture parts for anybody. Customers come off the street. We have customers across Canada, across North America, and so we'll make anything for anyone on a commercial level.
Parts move around different stations throughout the shop, starting with various saws. This is a power-fed vertical downcut saw with a high-speed steel blade. The material is brought to a preset stop according to the design plan. To adjust a stop, material is measured, the saw is started, and the speed adjusted. Compressed air blows shavings away. Today, they're cutting aluminum, but other materials like carbon and plastic are cut on this machine too. On the horizontal bandsaw, carbon pipe is cut on an angle. A coolant is also used. Each part is measured for accuracy. This metal lathe is used for turning both metals and plastics. The speed of a spindle and feed control this machine, and the feed and wheels set up materials. Today, bushings are being made and deburred. Here is a larger lathe cutting steel. Carbide inserts are used in most machines to do this cutting. Carbide is tungsten, stronger than steel. Here, a carbide end mill is milling a slot in plastic. Its table can go up, down, left, or right, and the drill can go up and down. It's used to mill, drill, and remove material. To set up material, most machines program X, Y, and Z axes. X sets left to right, Y sets in and out, and Z sets up and down. A verner is used to check dimensions and a deburring tool to deburr the part. To change a tool, the end mill is pulled out and a new one is selected and inserted. A smaller end mill is selected to match. The material is put on the vise and the part is referenced and set. Manual mills are used to cut single parts like this. Another large manual milling machine works on modifying a vehicle floor mat mold. It's adjusted from below to set its coordinates.
Our successes, I guess, they're rooted in our employees. Everybody's willingness to adopt to advanced manufacturing. Our growth, we're probably one of the fastest growing machine shops in Eastern Canada. We buy advanced gear so that it's a good place to work. The staff want to work with that equipment. That equipment can do stuff that no one else in Eastern Canada can, and we always want to be leading the charge in that purchase of those pieces of equipment.
CNC machines are used for complicated parts with big radiuses and high volumes. After it's programmed, the part is selected and clamped on the vise. Programs for parts are written and sent to this 5-axis CNC milling machine. The speed is set and the door closed. It mills, drills, and taps, threading holes. The table can spin and rotate angles, allowing for work on 5 sides at once. Today, stainless steel is delivered to their facility. The amount and quantity are checked. A forklift comes out to deliver it to the shop, where a 10-ton overhead crane is used to lift it to the automatic Swiss lathe machine's inventory. This does milling and turning for high volumes and precision parts. Materials are placed between feeder takes, which feed them through a main spindle, pinching them through the tool instead of the tool traveling along the material. This enables the feed rate and tool pressure to increase, creating a faster cycle. It takes 56 seconds to make one of these plunger body spring pins. In the fabrication building is a water jet. A vacuum lifter and overhead crane lift sheets of aluminum for profile cutting. The machine and monitor have their 0 or home position set. The pump is started, releasing 60,000 psi of water to cut the sheet. They also have two 5-axis water jet machines. These can cut on angles, not only at X, Y, and Z axes, but also at B and C axes. Finished sheets go to the plate deburring station to remove sharp edges and add uniform finishes. The table holds the plates by vacuum, and sanding belts and wheels do the work. Their 40-ton servo-electric press brake takes profile parts and bends, shears, and folds them. Hardened steel dies go on the bottom, and punches go on the top. A 165-ton hydraulic press brake is used for thicker and longer sheets of metal. After it's programmed, the dies and punches are selected and locked into place. The back gauge is moved into position, and the safety laser is adjusted for the new tool depth. It's tested, then the metal is placed and bent. In the welding department, metals are joined through the introduction of heat and filler materials. After welding, each piece is inspected. In the assembly department, parts are put together. In this case, jam nuts, bodies, poles, and pins are assembled. One of the last steps that parts undergo at ACE Machining is serialization. A transfer medium is applied to parts, they're loaded, the software is set, and the laser is run, leaving finished marked parts. Finally, all parts are checked in the quality control room. If all the specs are good, parts are packaged and ready to be shipped to ACE Machining's customers for the next step in manufacturing.